Hello, you are in Module 8 of Mathematics course. And in this module, we will be looking at set theory. In set theory, we study how well-defined objects called sets are collected. So it provides language and notation used across algebra, probability, logics, and statistics. So this module introduces definitions, methods of describing sets. If you have set, how do you describe them? How do you identify the types? Or how do you apply them to real life? So that is what this module is all about. So what is a set? A set is a well-defined collection of objects that share related property or that are similar. A set is a collection of well-defined similar objects. And you can describe a set by listing its elements. When we say elements, we are talking about the members of a set. When you hear elements of a set, what we simply mean is members of a set. So you can describe a set by listing its elements or by defining the property using column. For instance, look at the slide. B is such that, now B is the set, right? Then X is such that 3 is less than or equal to 10. Now look at it. You can use NA to denote the number of elements. Number of elements means number of members. Then if you want to say an element of a set, that is the symbol you are seeing there. So you use E for that it is an element of, but if it is not, you cross the E slightly. So indicating that it is not an element of a set. Then there's what we call equal sets. Equal sets are sets that contain identical elements. They contain what? Identical elements. They have what we call empty set. Empty set is a set that does not have any member or that does not have any element. Now, if you have, there are common notations. Let's look at that before we take some examples. There are common notations and operations we do as it relates to set. So, for instance, in set, there's what we call universal set. Universal set is just a set that contains every other set you can think of. All right? So, and we have subsets. Subsets are sets that are members of a universal set. So, there are concepts you come across like union of sets, intersection of sets, complement of sets, etc. So, for union of sets, if you have two sets, say A and B, if you want to get the union, union means all the elements that are from both sets. If A contains, say, 1, 2, 3, and B is 4, 5, 6, the union becomes 1, 2, 3, 4, 5, 6. You see, you combine all the elements. The intersection means only elements that are shared by both sets. So if a set A has 1, 3, 5, and another set has 2, 3, 5, what is common? The common element between them is 3. So we call it interset. So when you are asked to find the interset, that is what you look out for. What is common between the sets? Okay? Then complement. It can be gotten when elements in the universal set. A complement means elements that are in the universal set, but they are not in the subset. That is what is called complement. Alright? So you have to note this. Then in set theory, we make use of Venn diagram to visualize the relationship that exists between different subsets in a universal set. Okay? So we make use of diagram to map out given counts and regions and also to determine overlaps algebraically. Alright? So, look at this example. If A is a set containing 2, 5, 8, 11, 14, 17, and 20, and B is 2, 3, 5, 7, 9, and 11, while C is 5, 11, and 7, and D is 1, 2, 3, 4, you can actually draw the Venn diagram. You can see, if I say do A union C, it means you combine all what you can find in A and can also find in what? You can also find in C. Okay? Then, if I say A intersect B, that means what is common between A and B. Then if I say C union D, you already know what I mean. It means you are combining everything you can find in A and also in D. So let's look at that again. So you can see that how it is drawn. A and C, all of them are in the same set, but they do not have anything in common. A and C in that first diagram, in that first Venn diagram, you see that there is nothing common between A and C. But let's look at A and B. Okay, 2, 5, and 11 are common elements of A and B. You can see how it is drawn or it is visualized using Venn diagram. Okay, then for C union D, why are they separate? They are separate because there is nothing common between C and D. There is no member that is common to the both of them. Okay, now you can use Venn diagram to solve questions that are related to life. For instance, if I say in a club of 94 members, 60 like modern music, 50 like traditional music. Now, I may ask you to calculate the number that like both. I may also ask you to calculate the number that like none. Alright? So this will involve setting up algebra from region counts and solving for unknowns. The first step is assign variables to the unknown region. Then step 2 is write the total as sum of regions and solve algebraically. You can do it with 2 sets, you can do it with 3. For instance, if you have these 3 sets, a survey of 290 readers of a newspaper, 181 read Daily Times, 142 read Guardian, and 117 read Punch. You can visualize it using Venn diagram to see the overlap and also make your calculations. Okay? Now, where do we apply set theory? We can apply set theory in business, in agriculture, in sports, and in science and technology. Okay? Let me start with science and technology so that we see how do we apply set theory even in science and technology. I am saying this because, it is one thing to know that these concepts, mathematical concepts, are applicable to life. They are not just mathematical formulas and symbols. We apply them to different fields. So that is just the reason why it needs to be properly taught. Okay? So in science and technology, if you have heard of taxonomy, classification of living organisms, we make use of set because living organisms are classified based on similarity in their characteristics. So that is what Carolus Linnaeus in biology make use to categorize animals, okay? To classify animals either into kingdom, phylum, genus, or species, or even to determine the particular living organism that belongs to any kingdom, any phylum, any class, order, genus, or family. Alright, so it's applicable there because similar animals with related characteristics are put in one family. For instance, if you come to the family of mammals, you talk about man and monkey. You know that humans and monkey bears similar characteristics, so they are classified as mammals. So even in experimental grouping, we make use of set theory. In database structure, we make use of set logic. Okay. Even search engines and AI use set-based indexing when you want to index, and recommendation filters. When you go online, you want to search for something, you see that there is a way they are arranged that when you type in one, it will bring out others sequentially that are related to what you are searching for over the browser. Okay? In sports too, analysts group players by skills. Players are grouped by skills. Intersections find versatile athletes. You can look at speed and accuracy. they make use of that to form balanced teams and also design strategies. What of in agriculture? What do we use set theory for in agriculture? In agriculture, we use set, the knowledge of set, to classify crops by traits. The ones that resist drought, versus the ones that are in high demand. Okay? So we make use of that. So we can also use set to guide planting. We set intersections to inform resource allocation and even policy planning. In business too, business is not also left out. We use union and intersections to segment customers. For instance, the ones that buy online customers versus discount responders. So you also use the knowledge of set to create database of similar customers. Okay, so you can see that it is very important across all fields. So when you see any mathematical concept, do not just limit it to formulas, symbols. Okay? Don't look at it as if it is so abstract. You can actually apply it to life. You can see that even in when you want to organize your room, you want to arrange your room, you make use of the knowledge of set to know how to put similar things together. So you can see that the knowledge of set is very important in every walk of life, because set is all about arranging, organizing your things that have So that is it about set. Thank you for listening.